Heat. Activity. Take a piece of wood and a piece of metal and keep them in a fridge. After few minutes, take them out. What change you observe? Among those two, which is colder? And why? We know that we want to drink cool water. Just we place normal water in a refrigerator. When the water becomes cooler, that means water loses the energy, that is, heat energy. When a piece of iron and wood placed in a fridge, both are different material. We feel metal is cooler than wooden piece. What could be the reason for this? When you touch the metal or wooden piece, you feel that they are cold. When we feel that coolness, you know that heat energy is transferred from one body to other. Then, likewise, heat is transferred from your fingers to metal piece or wooden piece. If there is a contact between those two, then only heat transfer takes place. That is, if you remove your hand, you don't get the feeling coolness. When we feel the body is cool, that means the heat energy is transferred from your body to the metal piece. That is, you are losing energy, then you get a feeling of coldness. In the same way, when we touch a body, you get a feeling of hotness. That means the heat flows out from that body, that is, transferred from that body to you. Then you get a feeling of hotness. You can test this by bringing your finger near to the flame of a matchstick. So, if you feel that metal piece is cooler than that of wooden piece, it means that when you touch the metal piece, either more amount of heat energy transfer from your body, or when we touch a wooden piece, a less amount of heat flows out from your body. This can also be said that the degree of coolness of metal piece is greater than that of a wooden piece. Now, we have to know about the new term of physical quantity. To measure the degree of coldness or hotness present in your body, that is, temperature is defined as a physical quantity used to measure the amount of heat present in the body or the degree of hotness or coldness present in the body. When a body A have less amount of heat energy than the other body B, we say that body A is colder than B, or body B is hotter than A. Likewise, metal piece is having less heat energy. It is cooler, that is, they have less temperature than a wooden piece when we take out of the fridge. You know that water flows from up to down, like heat flows from hot body to cold body. But the heat transfer does not take place in all situations when two bodies they are at different temperature. Then heat energy flows from a body of heat temperature to a body of low temperature. This heat transfer does not take place at all. The transfer of heat takes place till both the bodies will attain the same temperature. That means up to the both bodies have the same degree of hotness or coldness. At this stage, we say that both bodies have achieved thermal equilibrium. It also be stated as a state of a body where it neither receives nor gives out heat energy. For example, in summer you feel so hot and in winter we feel so cold. That means atmosphere and your body and atmosphere are at different temperature. In summer, heat transferred from atmosphere to your body, and in winter, heat transferred from you to atmosphere till both attain the same temperature. In this situation, you are not feel either hot or cold in your surroundings. In the same way, we can say that the furniture and the air in the room are at the same temperature. What is temperature? How can you differentiate it from heat? To know the answer, let us do this activity. Take 2 cups and fill one of them with hot water and another in cold water. To measure the amount of heat, we take a thermometer and note that initial reading of mercury in thermometer. Keep it in hot water. Observe the changes in mercury level. Note the reading. Did the mercury level increase or decrease? Now, place the thermometer in cold water and observe changes in the mercury level. We know that the thermometer works under the principle of liquids expands on heating. When we place a thermometer in hot water, you observe that there is an increase in the mercury level. Because the heat energy transferred from hot water into thermometer, mercury present in thermometer. In the second case, you observe that there is a decrease in level of mercury because the heat transfer takes place from mercury to cool water till the thermal equilibrium is attained. Thus, we define the heat as follows. Heat is a form of energy in transit that flows from a body of high temperature to a body of low temperature, or the total internal energy present in the body is called heat. The steadiness of the mercury of the thermometer indicates that flow of heat between thermometric liquid and the water has stopped. Thermal equilibrium has been attained. The reading at thermal equilibrium gives the temperature. The temperature shown by a thermometer after attaining the thermal equilibrium is called equilibrium temperature. SI unit of heat is joule. CGS unit of heat is energy. Casually, we are saying the energy in terms of calories. Calorie is also one of the unit of heat energy. When the two bodies A and B are at different temperatures, are kept in contact with each other, the heat flows from hot body to cold body till the thermal equilibrium is attained. At this stage, both bodies will attain equilibrium temperature. Now, the two bodies individually thermal equilibrium with C, they both have the same temperature, so A and C are at same temperature. Similarly, B and C have the same temperature. Thus, B and C will attain the thermal equilibrium state. 1 calorie equals to at 186 joules. Unit of temperature, SI unit, is Kelvin. CGS unit is degree calories or degree centigrade. Kelvin is one of the scale used in the thermometer. No negative temperature will attain in Kelvin scale. So, it is called as absolute scale of temperature conversion of temperature from degree centigrades to Kelvin. C minus 0 divided by 100 equals to K minus 273 by 100 equals to C equals to K minus 273 equals to K equals to C plus 273. For example, O Kelvin on Kelvin scale is equal to minus 273 degrees centigrade on Celsius scale. Example, T in degrees centigrades equals to 30 degrees centigrade. K equals to 30 plus 273. K equals to 303 K. That is 30 degrees centigrades in Celsius scale is changed into 303 K in Kelvin scale. Temperature and kinetic energy. Take two bowls, one with hot water and second one with cold water, and sprinkle a weightless small balls on the water. What we observe? There is the motion of the balls takes place. How do they move? You will notice that they move randomly. Why do they move randomly? Because the molecules present in water have energy. With the help of that energy, they move randomly. Because of the motion, the water molecules' weightless balls also moving. The balls in which bowl move rapidly? The balls present in the bowl containing hot water moves rapidly. Why do the balls in hot water moves more rapidly than the balls on cold water? We know that moving bodies possess kinetic energy when they are in motion. If the hot body having more energy, so the water molecules in hot water moves faster than the molecules in cold water. So, they have different kinetic energies. The kinetic energy of particles of a hot body is greater than that of a colder body. So, hot body have more temperature than a cold body because the average kinetic energy of particles present in hot water is more. Like the average kinetic energy of particles present in cold water is less, so the temperature is also less. From the above explanation, we conclude that the average kinetic energy of the molecules is directly proportional to the absolute temperature. Activity. Take water in a container and heat it to 60 degrees centigrade. Take a cylindrical transparent glass jar and fill half of it with this hot water. Very gently pour coconut oil over the surface of the water. Take care that the water and oil do not mix. Put a lid with two holes on the top of the glass jar. Take two thermometers and insert them through the holes of the lid in such a way that bulb of one thermometer lies only inside the water and other lies only inside the coconut oil as shown in figure. Now, observe the readings of the two thermometers. The reading of the thermometer kept in water decreases, while At the same time, the reading of the thermometer kept in oil increases. Why does this happen? Because the heat energy transferred from hot water to coconut oil. Because of this transfer energy, the temperature of water decreases and the temperature of oil increases. The decrease in temperature of water irregularly to increase in temperature of oil. We know that temperature is directly proportional to the average kinetic energy. So, temperature of water decreases means average kinetic energy of water decreases. Temperature of oil increases means average kinetic energy of oil increases. We say that water loses heat energy. Now, we have a knowledge to differentiate the heat and temperature. Heat energy is the total internal energy present in the body and flows from a body of high temperature to a body of low temperature. Temperature is a measure of heat energy in number. We are representing the heat energy with the help of temperature. Specific heat. Take a large jar with water and heat it up to 80 degrees centigrades. Take 2 identical boiling test tubes with single-holed corks. One of them is filled with 50 grams of water and the other with 50 grams of oil, both at room temperature. Insert 2 thermometers through holes of the cork, one each into 2 test tubes. Now clamp them to a red rod stand and place them in a jar of hot water. Observe the readings of thermometers every 3 minutes. Note the readings in your notebook. In which test tube the temperature rises quickly? Are the amount of heat given to water and oil same? How can we say? We say that some amount of heat is supplied to both because they kept in hot water that have particular temperature for the same time interval. So, some amount of heat transferred from water to both bodies. We observed that the rate of rise in temperature of oil is higher than that of rise in temperature of water because the particles of water is not same as that of particles of oil. So, we conclude that the rate of rise in temperature depends on the nature of the substance. Activity. Take 2 beakers, fill the beakers with different quantities of water. Both beakers are at same initial temperature. Supply heat, then temperature of water in beakers, raise supply heat till both they attain the same temperature, that is T. We observe that to raise the temperature, the time required is more for the water have more quantity. From the above example, we say that for the same change in temperature, the amount of heat observed by the substance is directly proportional to mass. Amount of heat supplied is denoted by letter Q for same rise in temperature or same change in temperature, OT. Take again water in 2 different beakers, A and B, that is same quantity of water, to raise the temperature of water from room temperature to another. We supply heat energy with help of same burner supply heat energy. To increase the temperature of B than A, we give more heat energy to the burner. From the above observations, we conclude that the amount of heat required to raise the temperature of B than A is more. Q more means OT is also more. Q is directly proportional to OT. From 1 and 2, Q is proportional to MOT. Q equals to MSOT, where S is constant for a given substance. This is called specific heat capacity of substance. S equal to Q by MOT. It is defined as the amount of heat required to raise the temperature of unit mass of the substance by 1 unit or through 1 degree centigrade. Units: CGS units, calories per G minus OC. SI unit, joule per kg or Kelvin. 1 calorie G degree centigrades equals to 4.2 into 1000 joule per kg Kelvin. 1 calorie per G degree centigrades equals to 4200 joules per kg Kelvin. We know that rise in temperature depends on nature of substance, hence the specific heat capacity depends on nature of the substance. S is inversely proportional 1 by OT. That means S high, OT is low for same quantity of heat supplied. It gives an idea of the reductance of the substance to change its temperature. Applications of specific heat capacity. Method of mixtures. Situation 1. Take 2 beakers of the same size and pour 200 ml of water in each of them. Now, heat the water in both beakers till they attain the same temperature. If you pour this water from these 2 beakers in a large beaker, what is the temperature of mixture? Water present in both vessels are having same temperature. If we mix those water, then the resultant temperature of mixture is equal to temperature of water present in any vessel. So, thermal equilibrium is attained because both beakers are at same temperature. Situation 2. Now, heat the water in one beaker to 90 degrees centigrade and the other to 60 degrees centigrade. Mix the water from these beakers in a larger beaker. What do you observe? Measure the temperature of mixture. You notice that the temperature of mixture is less than the temperature of hot body and the temperature of mixture is more than 60 degrees centigrade. When these are at different temperature, heat transfer from a body of heat temperature, that is 90 degrees centigrade, to a body of low temperature, the particular temperature. This is the reason for this change in temperature. Situation 3. Now, take 100 ml of water at 90 degrees centigrade and 200 ml of water at 60 degrees centigrade and mix the two. Is there any change in temperature of mixture? What is the temperature of the mixture? For example, two bodies having water of masses M1 and M2, initial temperature of two bodies, be T1 and T2, equals to T1 is greater than T2. Then we mix the two. The final temperature of mixture be T. T is less than T1 and more than T2. The reason for the change in temperature is hot body loses the heat while the cold body gains the same amount of heat lost by hot body. The amount of heat lost by hot body T1 is greater than T. Q1 equals to M1 SOT. OT equals to T1 minus T. The amount of heat gained by cold body T2 is smaller than T. Q2 equals to M2 SOT. OT equals to T minus T2. M2S into T minus T2. Heat lost by hot body equals to heat gained by cold body. That is, Q1 equals to Q2 M1S into T1 minus T equals to M2S T minus T2. T equals to M1 T1 plus M2 T2 divided by M1 plus M2. You notice that the temperature of mixture in this situation 2 and 3 are not same because the masses and the initial temperatures of two bodies in these two cases is different. Can we find the temperature? We find the temperature of mixture with the help of thermometer. Principle of method of mixtures. When two bodies at different temperatures are brought into the thermal contact, the net heat lost by hot bodies equal to the net heat gained by the cold bodies until they attain thermal equilibrium. Net heat lost equals to net heat gain. This is the principle of method of mixtures. Determination of specific heat of a solid. Evaporation. When we boil the water continuously for more time, we observe that the water present in vessels disappears. Where does the water go? Similarly, when wet cloths dry, you will notice that water in the clothes disappear. When the floor of a room is washed with water, the water on the floor disappear within a few minutes and the floor becomes dry. What could be the reason for disappearance of water? Let us see. Take a few drops of spirit in two petri dishes, that is, a shallow glass or plastic cylindrical lidded dish used in the laboratory, separately. Keep one of the dishes containing spirit under a ceiling fan and switch on the fan. Keep another dish with its lid closed. Observe the quantity of spirit in both dishes after 5 minutes. What do you notice? You will notice that the spirit present in the dish that is kept under the fan disappears, but you will find the spirit present in the dish that is kept in the lidded dish. What could be the reason for this change? To know the answer for the question, let to know the new term or process of evaporation. The molecules of the spirit present in open dish collides continuously and as a result of this collision, they move randomly in all directions. They transfer energy to the other molecules. During this process, the molecules inside the liquid collides the molecules at the surface, acquires energy. With the help of this energy, they flow off from the surface. Of course, not all the molecules at the surface may flow off. Some of them comes into the liquid, but the number of escaping of molecules is greater than the number of returned. Finally, the molecules present in the liquid decreases. In this way, a liquid exposed to air, molecules at the surface kept on escaping till all the molecules escaping from the surface. In this way, a liquid exposed to air disappear. This process is called evaporation. The process of escaping molecules from the surface of liquid at any temperature is called evaporation. To know the reason for faster evaporation of spirit kept under the fan, if air blown over the liquid, then number of molecules returned from the surface of the liquid decreases. So, the rate of evaporation increases. This is the reason for the evaporation of liquid kept under the fan than that of kept closed. It means the temperature of a system falls during evaporation. It is a surface phenomenon. Here, the escaping of molecules state changes. Here, the molecules present in the liquid are in the liquid state of escaping. The state is changes to gas or vapor. So, evaporation can also be defined as the change of phase from liquid to gas that occur at the surface of liquid. It is a cooling process because the particles of liquid continuously give up their energy to the particles that are escaping from the surface. Now, we observe in our day-to-day life, while doing a work, we sweat. Why do we sweat? We do work means to spend some energy, then only work is done. This spending energy mostly in the form of heat energy from the body. As a result, the temperature of skin becomes higher by taking this temperature. The water present in the sweat glands starts evaporating. This evaporation cools the body because the excess heat developed is utilized by the molecules for evaporation. We know that temperature increases, then more molecules evaporate from surface. It is a surface phenomenon. So, surface area increases, rate of evaporation also increases. And it also depends on amount of evaporation already present in air and temperature, surface area. Condensation. The reverse process of evaporation is simply called as condensation. Take a glass tumbler filled with water, place the tumbler in a room having vapor. Now, what we observe? Vapor atoms moves randomly in all directions and collisions takes place in this process. The vapor atoms collide. The glass, as a result of collision, there is a transfer of energy takes place from vapor molecules to glass. So, the average kinetic energy of vapor molecules decreases they convert into liquid molecules. But the energy of glass tumbler is increases. It gives the heat to the water molecules present in the tumbler. As a result, the average kinetic energy of water molecules present in the tumbler increases. Hence, the total temperature of water present in tumbler increases. It is a warming process because during this process, temperature of water rises. In this process, state change takes place. That is, vapor molecules converted into liquid molecules because of releasing heat energy. It is also defined as the phase changes from gas to liquid. Daily life example. You feel warm after finishing bath with warm water on a sunny day or on a hot day. Why? What is the reason? The reason is that the vapor particles present in air be more in bathroom than in the surroundings. When the number of vapor atoms in the air present in the bathroom, so the vapor particles moves randomly in this motion. They collide the water particles present on the body, then give up the heat to the body. The temperature of body increases. Then you feel warm. Humidity. Some vapor is present in air always because of changing the temperature of air. This comes from the evaporation of water present in rivers, lakes, ponds, seas, from the drying of clothes and sweat and so on. This vapor molecules also having some pressure that is called humidity. The amount of water vapor present in air is called humidity. Boiling. Take a beaker filled with water. With the help of thermometer, note the reading of water. To increase the temperature of water, supply heat energy continuously. So, the temperature of water increases. Note the reading with thermometer for every 2 minutes. We observe that the temperature of water continuously increasing up to the thermometer shows the reading as 100 degrees centigrade. If the thermometer shows the reading as 100 degrees centigrade, till we are supplying heat, it is observed that there is no change observed in the thermometer. So, a question is arising. Temperature is a measure of heat. Even though we are supplying heat, the temperature does not measure the heat. Why? Where it goes? We observe a lot of bubbling at a surface of water at 100 degrees centigrade. This is what we call boiling of water. Why does this happen? Boiling is a process in which the liquid phase changes to gaseous phase at constant temperature at a given pressure. So, the heat energy given after the water comes to 100 degrees centigrade is utilized by the body to change the phase. The temperature at which water converts into gas is called boiling point of the liquid. The heat energy is used to change the state of water from liquid to gaseous state is called latent heat of vaporization. This is defined as the heat energy required to convert unit mass of liquid to gas at constant temperature is called latent heat of vaporization. Consider a liquid of mass m that requires heat energy Q calories to convert from liquid phase to gas. The latent heat of vaporization is Q by m. It is denoted by L. SI unit joule per kg, CGS unit calories per gram. The boiling of water at constant atmosphere pressure is 100 degrees centigrade or 373 Kelvin, and latent heat of vaporization of water is 540 calories per gram. Let us now consider the transformation of ice into water. Melting. Take a small ice cubes in a container. With the help of thermometer, measure the reading of temperature of ice in a container. Now, to increase the temperature, supply heat energy to the container. Note the reading shown by the thermometer. It is observed that there is no change in the temperature of ice, even though we are supplying heat energy. Where does the heat energy supplied go? The supplied heat energy is utilized to change the state of a body or to change the solid state to liquid. When this heat the ice completely melt into water. We are not observing any change in temperature of the matter present in vessels. The process of changing the temperature of solid into liquid is called melting. The temperature at which solid converts into liquid is called as a melting point. The amount of heat energy required to convert 1 gram of ice into liquid at constant temperature is called latent heat of fusion. Consider a solid of mass m. Let Q be the amount of heat required to convert solid phase to liquid phase. The heat required to change 1 gram of solid into liquid is L steam equals to Q by m. L steam equals to 80 calories per gram. Freezing. You might have observed the coconut oil and ghee getting converted from liquid state to solid state during winter season. What could be the reason for this change? What happens to water kept in the refrigerator? The water is kept in refrigerator. The initial temperature of water is more compared to temperature of ice. It means during the process of conversion from liquid to solid, the initial energy of water decreases so that it becomes a solid ice. This process is called freezing. The process in which the substance in liquid phase changes to solid phase by losing some of its energy is called freezing. Freezing of water takes place at 0 degrees centigrade temperature and at 1 atmospheric pressure. Are the volumes of ice and water are equal, and why? Activity. Take a glass bottle completely filled with water. Now place the bottle in a deep fridge. After few hours from the refrigerator, the glass bottle breaks because the volume of ice is more than the volume of bottle, but the volume of water is equal to volume of bottle. That means volume of formed ice more than water becomes after freezing the number of atoms present in unit volume be more, so mass per unit volume, that is density of it less than water volume of ice is more than water or bottle. Because of this reason the bottle breaks.